Hi everyone, in this lecture I am going to discuss one more problem for finding all the super keys from the given relation. In previous lecture already I have discussed what is a super key, how to find out all the super keys from the given relation. Please check out the previous video once. Now I am going to start today's class. In this class I will discuss this problem. This problem relation R consists of A, B, C, D, E attributes and set of functional dependencies are given. A determines B, D determines C. For this problem you need to find out all the super keys from the given relation. For this problem we need to find out all the super keys from the given relation. So before going to that problem, what is a super key? What is a super key? Super key is a key whose closure contains all the attributes of a given relation. Any attribute closure or set of attribute closure consists of all the attributes, then it would be a super key. So what is the procedure to find out all the super keys from the given relation? The procedure is, first you have to identify the possible super keys. First we have to identify the possible super keys from the given functional dependencies, and then you have to identify all the super keys. First we have to identify the super key. From that super key we have to identify all the super keys. So that is the procedure you have to follow. So first I will identify the super keys from the given functional dependency. How to identify the super key? So how to identify an attribute or set of attribute is a super key or not? We have to find out the closure. We have to find out the closure. If the closure consists of all the attributes, then it would be a super key. Otherwise it is not a super key. So first I will find out a closure. First I will find out a closure. So what is a closure? A closure itself determines A. Because of reflexive rule, an attribute itself determines A. Itself determines A. By observing this functional dependency, A determines B. Using A, we can determine B. Here I am having A, so you can determine B. Can I add any attributes to the A closure? No, I cannot add any attributes to the A closure. A closure consists of only A comma B. A closure consists of only A comma B. Is A super key? No, A is not a super key. A is not a super key. Why A is not a super key? If A is a super key, this closure consists of all the attributes. So what are the attributes of the given relation? A, B, C, D, E. But A closure consists of only A, B. So A is not a super key. Next, find out B closure. Find out B closure and check it is a super key or not. So what is B closure? B closure itself determines B. B closure itself determines B. Because of reflexive rule, an attribute itself determines B. Can I add any attribute to the B closure? No, I cannot add any attributes to the B closure because from B there is no functional dependency. So only B. B closure consists of only B. Is B super key? No, B is not a super key. B is not a super key. Why? Because B closure consists of only B. B closure consists of only B. So B is not a super key. How to identify an attribute or set of attribute? Then it will become a super key. So how to identify an attribute or set of attribute? We need A, B, C, D, E attributes as a result. As a result. If I take A, then we can determine B. If I take A, then we can determine B. So no need to write B. If I take D, then we can determine E. No need to write E. If I take A, then we can determine B. If I take D, then we can determine E. So no need to write again B. No need to write again B. So what is the remaining attribute we need? So the relation consists of A, B, C, D, E. Using A we can determine B. Using D we can determine A. So what is the remaining attribute? C. We need C. So you can add C. You can add C and find out the closure. Find out the closure. Now find out the ADC closure. ADC itself determines A, D, C. If you have A, then you can determine B. If you have D, then you can determine A, E. So ADC closure consists of A, D, C, B, E. ADC closure consists of all the attributes. So ADC is a super key. ADC is a super key. So identifying attribute or set of attribute is important. That becomes a super key. Based on the functional dependencies, we can identify the attribute or set of attribute. Then it will become a super key. So after finding a super key, we need to find out all the possible super keys. After finding a super key, we need to find out all the possible super keys. So how to find out all the possible super keys? Here ADC is a super key. So what are the remaining attributes except ADC? What are the remaining attributes except ADC? B are the remaining attributes. If ADC is a super key, then the combination with remaining attributes would be a super key. If ADC is a super key, the combination with remaining attributes would be a super key. So what are the possible combinations? What are the possible combinations? So already I explained in previous video how to take the combinations. So BE, how many attributes? Total 2 attributes. So 2 square, that equal to 4. We will get 4 super keys finally. We will get 4 super keys. So what are the combinations? First one is ADC is a super key. ADC is a super key. ADCB is a super key. ADCBE is a super key. ADCE is a super key. So these are the 4 possible super keys for this problem. So for this problem, the total number of super keys equal to 4. How to find out these set of attributes are super keys or not? If you have any doubt, then find out the closure. ADC, already I find out. ADC consists of all the attributes, so it is a super key. ADCB itself determines ADCB. If you have D, then you can determine E also. So it is a super key. ADCBE, it consists of all the attributes. So ADCB itself determines all the attributes. It is also a super key. ADCE, here there is no B, but using A we can determine B. ADCE consists of all the attributes. This is also a super key. So these are the possible 4 super keys for this problem. Okay, thank you.